This is Power Electric and Engineering LLC bringing to you the distributed control system using PLCs and VFDs along with fans or motors, AC motors, to demonstrate the prototype of a distributed control system for creating or cleaning up the air in a garage, multi-level garage system. Here we see the PLC Click PLC. This happens to be the slave device, if you will. Here's different relays that control the motors and wiring blocks and so forth. Here we have a couple of small DC solar panels which generate DC voltage when exposed to the sun. They are simulating the gaseous sensors, if you will, nitrogen and nitrous oxide, carbon dioxide, that would be in the air in a carport or a multi-level parking garage. This is the DC drive. This is a VFD for the three-phase motor. This is the master PLC. Some additional hardware here that's not being used in this particular project. Here's the Automation Direct Seymour Micro touch screen interface, human interface. Here's the motors, as you can see, or here are the motors. A small 1 horsepower three-phase motor and an AC motor, single phase 820 volt, and another 120 volt AC motor. These simulate fans for CO2, and it simulates a fan for the nitrous oxide. Now, as you can see, they're running right now, but if we simulate, and the sun's outside right now, but if we simulate a different amount of gas in there, first of all, let's take a look. We're showing right now that we have 24 ppm of carbon dioxide and 8 ppm of nitrous oxide. Now I've wired it up such that this sensor is simulating carbon dioxide. I'm going to cover this. Now I've covered this, and one of the fans, the second fan, has been turned off. Now let's take a look at this. This is 5 ppm. Because of the sunlight, in order to turn off both the fans, we'd have to cover this sensor up. But as you can see, the nitrous oxide fan is still going. So let's put another filter, if you will, or cover on this. And as we'll see, okay, now let's take a look. It's gone down to 7 ppm. The indication says it's still on, but we can see number 2 is off, as it surely is. Number 1 fan's on, and one of our small enunciators there is lit, and then the high one is indicating that in fact we have a low level of nitrous oxide. Now if we take a look at the motor here, we can see that it's on a lower RPM. And let's take a quick look at the VFD. It's at 25 hertz. Now if I can cover up the solar panel, now we have completely shut off the three-phase motor because we have insufficient. Take a look here, we only have 1 part per million simulated here, so we've shut off the three-phase motor. Now let's turn everything back on. We'll go full bore. And as you can see, the motor's going here, the motor is going here, and the three-phase motor is going on. So all the motors are on, and the indication is 9 ppm, 25, everything's on. Now because it's a distributed control system, we have modbus RS232 communication between the two PLCs. Now the nice thing about this, if the modbus communication link, which is only a few wires, I think 6 wires here, so it reduces the construction cost, installation cost. But if the comm link goes down between the master and the slave, The slave PLC, which is this one, will continue to operate and operate the fans to keep the toxic gas levels low in the parking garage. We can simulate settling by just turning this off, but nevertheless, this gives an idea of the distributed control. This would be for the supervisory personnel, maintenance personnel in the office to make sure that the system's running properly. And this would be located out in the parking garage, close adjacent to fans and sensors. This is Power Electric and Engineering LLC, bringing you concepts in PLC logic and control using Automation Direct products. Thank you.